let's try to really clarify this idea so we really understand it. F of t stands for depth in centimeters. F prime of t is the rate of depth change in centimeters per second, let's say. Then what does delta F prime over delta t stand for? Well, this is the change in the rate of depth change divided by the clock time over which that change occurs. So that this is the average rate of change at which F prime changes. Okay? Now F prime is just the rate at which the depth changes, so that this quantity is the average rate at which the rate changes. So be sure that you understand that idea and that terminology. If we take the limit as delta t goes to 0 of the average rate at which the rate changes, we have limit of delta t goes to 0 delta F prime over delta t. Well, that's just F prime prime. Now why do we say that? Well, first of all, the limit as delta t goes to 0 of delta y over delta t is y prime for any function of t. That's our definition of what y prime means, and that's a definition of what the derivative or rate of change function means. If then y equals f prime, as it does in this case, because we're taking delta f prime over delta t, so if the thing we're doing the delta on top of here happens to be an f prime, then we're going to say y equals f prime. So if y equals f prime, then it's going to follow that y prime is just f prime prime. And we call that f double prime, and we call that the second derivative. Again, it can be thought of as the rate at which the rate changes for the function f.